Welcome back. I'm Mo Malone, and in our previous episodes, we've explored various approaches to processing and understanding text. Today, we're diving into what might be the most revolutionary development in NLP, neural networks. These powerful models have transformed how machines understand and generate human language. Imagine teaching a computer to not just process words, but to understand context, capture subtle meanings, and even generate human-like responses. Neural networks make this possible by mimicking, in a simplified way, how our own brains process information. Let's start with a practical example. When you use a modern translation service, you're interacting with a neural network that can understand the nuances of language well enough to preserve meaning across different languages. Today, we'll uncover how these systems work. Understanding neural networks at their core. Neural networks are sophisticated pattern recognition systems. Basic components. 1. Neurons, nodes, input processing, weight adjustments, activation functions, output generation. 2. Layers, input layer, hidden layers, output layer, layer connections. 3. Training process, forward propagation, error calculation, backpropagation, weight updates. Let's see how these components work together for NLP tasks. Feed-forward networks for text. The simplest neural networks for text processing are feed-forward networks. Architecture. 1. Input layer, word embeddings, text features. 1. Hot encoding, dense representations. 2. Hidden layers, pattern detection, feature combination, nonlinear transformations, representation learning. 3. Output layer, classification, scores, probability distributions, regression values, decision boundaries, example applications, text classification, sentiment analysis, language identification, topic categorization. Recurrent neural networks, RNNs revolutionized sequence processing in NLP. Key concepts. 1. Sequential processing, time steps, hidden states, memory cells, information flow. 2. Variant, simple RNN, LSTM, GRU, bidirectional RNN. 3. Applications, text generation, machine translation, sequence labeling, language modeling. Let's explore how RNNs handle text. The cat sat on the mat, word by word processing, context accumulation, pattern recognition, sequence understanding. Long short-term memory, LSTM networks, solve the long-term dependency problem in RNNs. Components. 1. Gates, input gate, forget gate, output gate, cell state. 2. Memory management, information storage, selective forgetting, update mechanisms, output control. 3. Advantages, long-term dependencies, gradient stability, selective memory, better learning applications, document summarization, story generation, dialogue systems, time series prediction. Convolutional neural networks, CNN. While traditionally used for images, CNNs excel at text tasks too. Text applications. 1. Feature detection, n-gram patterns, phrase recognition, local features, hierarchical patterns. 2. Architecture, convolution layers, pooling layers, dense layers, skip connections. 3. Benefits, parallel processing, local patterns, position invariance, efficient training, example tasks, sentence classification, document categorization, feature extraction, pattern recognition. Attention mechanisms, attention revolutionized how neural networks process sequences. Key concepts. 1. Attention computation, query vectors, key vectors, value vectors, attention weights. 2. Types of attention, self-attention, cross-attention, multi-head attention, global versus local. 3. Benefits, parallel processing, long-range dependencies, interpretable focus, better performance applications, machine translation, document summarization, question answering, information extraction. Hash transformer architecture. Transformers have become the dominant architecture in modern NLP. Components. 1. Encoder self-attention layers, feed-forward networks, layer normalization, residual connections. 2. Decoder masked attention, cross-attention, feed-forward networks, output generation. 3. Positional encoding, position information, sequence order, relative positions, temporal relationships, applications, BERT-like models, GPT series models, T5 and variants, modern NLP systems. Hash training neural networks. Successfully training neural networks requires careful consideration. Key aspects. 1. Data preparation, text pre-processing, batching, padding, augmentation. 2. Loss functions, cross-entropy, mean squared error, custom losses, multitask objectives. 3. Optimization, learning rate, batch size, gradient clipping, regularization. 4. Monitoring, validation, metrics, learning curves, error analysis, performance tracking. Hash advanced techniques. Let's explore cutting-edge approaches. 1. Transfer learning, pre-trained models, fine-tuning, domain adaptation, few-shot learning. 2. Multitask learning, shared representations, task relationships, joint training, knowledge transfer. 3. Neural architecture search, automated design, hyperparameter optimization, efficient search, performance optimization. 4. Interpretability, attention visualization, feature importance, decision explanation, error analysis. Hash real-world implementation. Practical implementation requires careful planning. 1. Infrastructure, hardware requirements, software stack, distributed training, deployment options. 2. Pipeline design, data flow model, training, evaluation, deployment. 3. Production considerations, scalability, monitoring, updates, maintenance. 4. Quality assurance, testing, validation, error handling, performance monitoring. Hash future directions. The field continues to evolve. 1. Efficient models, model compression, knowledge distillation, quantization, sparse models. 2. Multimodal systems, text-image models, speech-text integration, cross-modal learning, unified representations. 3. Continual learning, adaptive systems, lifelong learning, knowledge retention, dynamic updates. 4. Ethical considerations, bias mitigation, fairness, transparency, responsible AI. Hash closing. As we conclude our exploration of neural networks in NLP, remember, architecture matters, training is crucial, evaluation is essential, implementation details count, ethics guide development. In our next episode, we'll explore convolutional neural networks in more detail. Until then, try this exercise. 1. Implement a simple neural network. 2. Experiment with different architectures. 3. Train on text data. 4. Analyze performance. 5. Visualize results. I'm Mo Malone, and thank you for joining me in this journey through neural networks in NLP. Remember, every neuron counts, and every connection matters. Keep learning, keep implementing, and I'll see you next time. Stay curious, and keep training.